Good morning to all. Welcome back to my channel. Today I'm going to appear the Computer Networks and Internet Protocol of January 2025 NPTEL's assignment questions week 10 assignment 10, which last date is 2nd April 2025. Okay, now we'll try to attempt this question, guys. You can see this is week 10 assignment 10. Questions are there and you can find near about 10 questions. We'll try to attempt the 10 questions with detailed explanations one by one. Now let's start the first question here. The first question is asking about the CSMA or CD predominantly used in Ethernet address. Which of the following challenges? Which of the following challenges it is facing? First one is efficient encoding and decoding of data signals. Second is synchronization of devices in wireless network. Third one is detection and management of data collisions in the shared media network. Yes, the option C, you can choose one. Option C is the appropriate answer. You can see, guys. So why we choose the detections and management of data collisions in shared media network? What happens actually in CSMA or CD? You can say that the carrier sends multiple access with collision detection is a protocol. It is used in Ethernet network to manage access to shared mediums. It addresses the challenges of collisions which occur in the multiple devices attempt to transmit data simultaneously on a shared medium. That is, CSMA or CD works by three approaches. That is called sensing the medium to check if it is free, that is carrier sense. Second one is transmitting if free but listening for collisions, that is collision detection. And the third one is if collision is detected, it stops transmissions, sends a jam signal and retrieves after a random backup period. So why here you choose option A is incorrect, because encoding or decoding is handled at a physical layer, not by CSMA or CD. Option B is also incorrect because as a CSMA or CD is a wired Ethernet, not a wireless network, which use CSMA or CD. Option D is also incorrect because CSMA CD operates within a single broadcast domain, not across multiple domains. So in this context, only the option C, that is detection and management of data collision in shared media network is the challenges. Now moving to the question number 2. Which MAC technique is most suitable for rusty traffic with sporadic transmissions? Okay, which one is? That is synchronous MAC with the reserved slot, asynchronous MAC with the round robin allocations, token passing in a ring topology, and a contention based asynchronous MAC. That is, the most appropriate option would be option D. Okay, option D. Rusty traffic with sporadic transmissions means data is sent in irregular manner, unpredictable process. So in option A, synchronous MACs with reserved tools means synchronous MACs with reserved slots is inefficient for rusty traffic because slots are pre-allocated, leading to wasted slots when there is no data to send. And second one is asynchronous MAC with round robin allocation ensure each station gets a turn, but is not ideal for a sporadic traffic as it enforces a rigid order, potentially delaying on urgent transmissions. And the third one is token passing in ring topology with guarantees across but introduce latency as station must wait for the token, which is inefficient for rusty traffic. But the last option, only the contention based asynchronous MAC, that is CSMA, allows station to transmit whenever they have data, provided the medium is free. This is well suited for rusty sporadic traffic as it does not rely on fixed schedules or tokens. That's why we choose option D is the correct option. Okay. Now moving to the question number 3. The question number 3 in go back and ARQ, why must the size of the sender windows be less than 2 to the power m, where m is the number of bits in a sequence number. So most appropriate answer would be to avoid ambiguities in the sequence number during the retransmissions. Okay, 3 option D would be the most appropriate answers. In go back and ARQ, the sender can transmit multiple frames up to the window size before receiving the acknowledgement. The sequence number of assigned using m bits, so the range of the sequence is 0 to 2 to the power m minus 1. If the sender's window size is equal to the greater than 2 to the power m, the sequence number will be what? Around too quickly cause ambiguity. For example, if m equal to 3, the sequence number is 0 to 7 and the window size is 8. The sender might send the 0 to 7 and then reuse 0. If an ACK is lost, the receiver might confuse a new frame 0 with retransmitted 0 from the previous cycle. So to avoid the ambiguity, during retransmission, the sender window size must be less than 2 to the power m into the 2 to the power m minus 1. So A is incorrect. Why you choose A is incorrect? Because go back and does not accept out of order frames. It discarded them. Then second one, B is also incorrect, as cumulatively ASK works regardless of window size as long as ambiguity is avoided. The last option C is eugenic. Opt as incorrect because the receiver window size go back and is 1, not later to the sender's windows. The last one is the correct answer to avoid the ambiguity in the sequence number during the retransmission. Okay. Now moving to the question number 4. What is the minimum frame size for the Ethernet IEEE 802.3 and why it is important? Why it is important? It is important because 64 bytes to ensure collision detection within the frame transmission times. That is 4 option B. 4 option B. See, in Ethernet IEEE 802.3 using CSM or CD, minimum frame size is 64 bytes, including the header data and including the pre-removable and SFD. The size ensures the collision can be detected within the frame transmission. So the CSMA or CDA sender must still transmitting when the collision signal from one fastest node, that is reaches it, so it can detect the collision and stop. The minimum frame size guarantees that the transmission time is least twice propagation delay across the network, that is to the account for the round trip time. So for the 10 Mbps Ethernet with the maximum cable of 2500 meters, the round trip time ensure the requirement is met with a 64 byte frame. So A is incorrect because 46 byte is the minimum data payload size, that is total frame size must be 64 bytes. Option C and D are incorrect because 512 bytes and 1500 bytes are much larger than the minimum requirement. That is 1500 byte is the maximum frame size for the Ethernet. That's why only we choose option the B, that is 64 byte to ensure the collision detection with the frame transmission time. Okay, 4 option B. Now moving to the question number 5. In a selective repeat ARQ system with a 4-bit sequence number and a sender window size of 8, what is the minimum size of receiver buffer to prevent loss out of the order frames? That is, if you calculate, now we have to calculate. So after calculating, we choose the 5 option. Option B is the appropriate answer. How? Let's calculate. In a selective or repetitive ARQ, the receiver can accept out of order frame and buffer them until missing frames are received. A 4-bit sequence means there are 2 to the power 4. 2 to the power 4 means 16 possible sequence number, that is 0 to 15. The sender window size is given as 8. In a selective repeat, the receiver window size must be equal to the sender's window size to handle out of frame effectively. To ensure that the receiver can buffer frame that arrive out of a sequence without losing them. If all the receivers window size were small, that is 4, it might not have the enough buffer space to store all out of order frames, leading to frame loss. The receiver buffer size must match the window size, which is 8 in this case. So if you choose option A, that is 4 is very too small. Yes. If you choose 16 is unnecessarily large. Yes. Then if you choose option D, 1 is insufficient for out of order frame. So the correct option is option B, that is 8. Now moving to the question number 6. Question number 6. In a wireless CSMA or CA network uses a backlog algorithm with a contention window size that doubles after each collision. If the initial contention window size is 32, what is the maximum contention window size after 4 collisions? After 4 collisions. After 4 collisions, if you calculate, it will be 512. Let's see. I will let you know that how it will be 512. See, in CSMA used in a wireless network like Wi-Fi, the connection window, that is CW size, doubles after each collision. Doubles after each collision to reduce the likelihood for further collisions. So the initial CW is 32. Remember, the initial collision is 32. After first collision, what will be 32 into 2, that is 64. After second collision, 64 into 2, 128. After third collision, 128 into 2, that is 256. After fourth collision, that is contention window will be 256 into 2, that is 512. 512. So the maximum contention window size after 4 collision is 512. So now come to the various options. If you choose option A, there is 256 size after 3 collisions. If you choose option C, that is 128 is the size after 2 collisions. Option D, 1024 is the size after 5 collisions. So after 4th collision, it is asking about after 4 collisions, after window size after 4 collisions, after 4 collisions it will be 512. Okay, so 6, option B. Now moving to the question number 7. Question number 7. In a shared 75 kbps channel, each station transmits 20 bit frames every 2000 milliseconds. If the network uses slotted alpha, what is the maximum number of stations that can be supported? Now, first calculate how this maximum number of stations can be supported. Now, let's calculate these things. So, to determine the maximum number of stations that can be supported in a slotted halola, we use the various steps are there. So, first, each station transmits 22 bits frame, that is 2000 milliseconds. That is 2000 milliseconds, that is 2 seconds. So beats per channel is 75 kbps. 75 kbps in the question, that is 75,000 bps. So transmission rate equal to R by E. Yes. Okay. 20 beats by 2 seconds, that is 10 bps. First one is correct. First one is 10 bps. Now come to the step number 2. In step number 2, in slotted Aloha, the maximum channel utilization is 37% of the total capacity. So maximum supported set point, you know the formula, n equal to 0.37 into channel bandwidth by transmission rate per second. So n equal to 0.37 into 75,000. Okay, what is 75,000? 75,000 is BPS, bit rate per channels, by 10. So if you calculate, it is 27,750 by 10, that is 2775. That is 2775. So the maximum number of stations that can be supported is 2775. This one. So we choose option B. Clear? Now moving to the question number 8. Consider a CSMA or CD network where the frame transmission TF frame transmission is much larger than the propagation delay TP. Which of the following factor affect the efficiency of the network? Which of the following factor affects the efficiency of the network? So frame size, definitely it will affect it. And second is propagation delay. Yes. Backup time after a collision. Yes. Total number of collisions. All are true. Okay. 8, option C, all are true. Now I'm going to explain how we choose the all are the true options. See, the first one. The efficiency CSMA or CD network depends on the several factors. Fact factors. Frame size. Large frame increase efficiency because the transmission time dominates over the propagation delay, reducing the relative overhead of the collisions. Second options, propagation delay. A large propagation delay increase the likelihood of the collisions going to undetected, reducing efficiency. And the third one is backup time after a collision. That is longer backup time after collision. Reduce the chances of a repeated collision but increase the ideal time, affecting efficiency. And the last one, that is total number of stations. More station increases contentions, leading to more collisions, lower efficiency. Since all the factors impact the efficiency of a CSMA CD network, so we choose the correct option, that is all as the true options. So 8 option C. Now moving to the question number 9. In a round robin match technique, the network has 10 stations and each station gets a time slot of 2 milliseconds. If a station has a data framework of 2 KB transmit, the transmission rate is 1 Mbps. How many rounds it will take for the station to complete the transmissions? Okay, to complete the transmissions, it will take near about 16. Okay, how many rounds? That will 16 rounds it will take for the station to complete this transmissions. Now let's see how the 16 will be. You can see the data framework size, that is 2 kbps. You can see 2 kbps, 2 kb. So 2 into 1024 into 8, that is equal to 16,384 bits. We have to convert it bits. That is 2 into 1024 into 8, that is 16,384 bits. Second is transmission rate. 1 Mbps equal to how much? 10 lakhs bits per second. Yes or no? Transmission rate 1 Mbps equal to 10 lakhs bits per second. Time to transmit the entire frame. So previously you know the entire frame, that is data frame size by transmission rate. What is the data frame size? Data frame size was 16,334 by transmission rate, that is 10 lakhs bits per second. So 16,334 by 10 lakhs, it will be 0.01638 second. That is equal to 16.384 ms. Now, in a round robin, first consider the round robin. Each station gets 2 ms slots per round. Data transmitter slot equal to 2 milliseconds. So 2 milliseconds into how much? 10 lakhs bits per second. That is equal to 2000 bits. Here, number of slots needed, that is 16,384 bits by 2000 bits per slot. That is equal to 8.192 slots. Since a station gets 1 slot per round, there are 10 stations, so each round takes 10 slots, 1 for each station. So however, the station only transmits its own slot. The station needs, we know the station needs 8.192 slots, but since the slots are discrete, it requires 9 slots, selling of 8.192. However, it lets the total time needed is 16.384 milliseconds. So each round takes 10 station into 20 into 2 milliseconds, that equal to 20 ms. But the station only transmit for 2 milliseconds per round. So in first round, the station transmit 2000 bits. So total round needed 16,384 bits by 2000 bits per round. It will be 8.192 rounds, which round up to 9 rounds. So the option do not include 9 option. Is there any option for 9? No option. That's 9. So let's consider the total transmission time. So in 8 rounds, the station transmits 8 into 2000, that is equal to 16,000 bits, which is not enough. Needs how much it needs? It needs 16,384, but our calculation is 16,000 bits. So in 16 rounds, the session transmits 16 into 2000, that is equal to 32,000 bits, which is more than enough. Okay, here the question is likely assume a different interpretation, but based on the closest match, 16 round ensure the transmission is completed. That's why we choose the correct option C, that is called the 16. Okay, C option 16. Now moving to the question number 10. A network administrator is analyzing a collision on a traditional Ethernet network using CSMA or CD. They observe the following sequence. What they follow? A no transmit frame after sensing the medium is free. Okay, the collisions occurs detected by violate the fluctuations and a jam signal is transmitted and a node is applied to a backup algorithm. If the backup limit is reaches without successful transmissions, what should be known to the next? What should be known to the next? The next would be it abort transmissions and report a failure. 10 option C. 10 option C. That is, it abort the transmissions and report a failures. In Ethernet with CSM or CD after a collision, a node sends jam signal and ensure a backup fetch, doubling or contention window each time. That is up to limit. The backup limit is typically 10 in Ethernet, refers to the maximum number of retry attempts. If the backup limit reaches after the 10 collisions, the node assumes the network is too congested and aborts the transmission, reporting failure to the upper layer. Okay. Next, A is incorrect because retrying immediately without sensing it violates the CSM or CD rules. Okay. Second one, B also incorrect because continuing to backup identify is not standard behavior. Ethernet has a retry limit. Ethernet has a retry limit. And D is also incorrect as the switching protocol is not respond to reach the backup limit. Thus, only the option, that is option number C, it aborts the transmission and report a failure. Clear? Now, guys, you can see we successfully attempted all the questions. Now, once again, we have to verify the answer. Question number 1, we choose option number C. Question number 2, we choose D. Question number 3, D. Question number 4, you can choose B. Question number 5, you choose B. Question number 6, we 500 B, that is 512. Okay. Question number 7, B. Question number 8, question number 8 C, question number 8 C, question number 9 C, question number 10 C. Now I am going to submit the answer of these questions. Please wait, the assignment is submitted. Thank you for taking week 10 assignment 10. Your answers are successfully submitted. We explain all the questions, its answer with a detail. Okay, so if you like this video, you can share with your friends and colleagues, and you can subscribe our channel for the upcoming week 11 assignment 11 solutions. Guys, you have any questions, you can put your question in our comment box. You are welcome. I will try my best to give the answer to your questions. Okay, thank you for watching my complete video. Take care of yourself. Goodbye.